In match problem 7, we're given a function that represents sales based off our advertising campaign. So N is the number of television sets that we're selling monthly. We're spending X thousand dollars in some advertising campaign. So what we want to know is, when is the rate of change of sales increasing? When is it decreasing? What's the point of diminishing returns? And what's our maximum rate of change of sales? So essentially what we're after is a point somewhere in this region. So with minimums, maximums, sometimes it's a little easier to visually pick those out, but for inflection points, when we're trying to find that inflection point, it's a little bit trickier to identify where is that exact value where this function changes from concave up to concave down. So in finding it, we'll find our point of diminishing returns. We'll find the point when the increase in sales from our advertising campaign has started to slow down. So that advertising campaign is still increasing sales, but isn't giving us as big of a return on our investment as we initially started off with. So we begin exactly the same way. Find the first and second derivatives. And then we take that second derivative and set it equal to 0 to find any critical values. So factoring is going to give us 3x times 8 minus x is equal to 0, which means we have critical values at x equals 0 and x equals 8. So at x equals 0, we have a critical value, and at x equals 8, we have a critical value. Now, if we look back at the function that we're given, the domain for this function is restricted to values between 0 and 12. So the smallest amount of money we'll spend on this advertising campaign is 0. We can't spend negative money on it. So any values less than 0, we're not concerned with. We're just concerned with what's happening to the left and to the right of this single critical value. So we can choose our test points and evaluate the second derivative at 1, which in this case would give us 21. So our graph is concave up, and at the second derivative evaluated at 9 would give us negative 27. So our graph becomes concave down. So since our graph changes from concave up to concave down at x equals 8, we know that x equals 8 is an inflection point. And again, specifically, since it changes from concave up to concave down, then it's also the point of diminishing returns. So what we're saying is, if we spend more than $8,000 on this advertising campaign, we'll still be increasing sales, but that increase is going to start to slow down. So we're still seeing a return on that investment. Sales are continuing to increase. It's not like spending money on the advertising campaign is causing us to lose money or lose sales. But we really, in this first bit, from spending between $0 and $8,000, that's when we really saw that maximum rate of change, or the maximum increase in our rate of sales. Beyond that, we're still increasing sales, but we're not getting as much back in exchange for how much money we're investing in the campaign.